For example, let's do some integrals. Let's say we want to find the integral of 6 sine x plus 3 over x minus the square root of x plus 2e to the x. Let's just throw one more in there, plus 1 over the cube root of x. Get a whole bunch of all rules into one question. So the very last property from that previous page said that if you're taking the integral of like f plus g, you use integrate f, then integrate g, and so on and so forth. So we integrate each of these one at a time. So 6 sine x integrates to negative 6 cosine x. 3 over x, that is 3 times 1 over x. So that integrates to 3 times log absolute value of x. Right? Because again, 3 over x is 3 times 1 over x. Negative root x, well that's x to the 1/2. So we add 1 to the exponent, so it's x to the 3/2. And we divide by the exponent. When you divide by 3/2, multiply by 2/3. 2e to the x, that's the easy one, integrates to itself. 1 over x to the 1/3 power, that's x to the negative 1/3. So when you add 1 to the exponent, it gives you 2/3. Divide by 2/3 is times 3/2. And don't forget the plus c. Losing a point because you forget the plus c is one of the most painful points for me to take away. So don't forget plus c. And then if you have time, you can just find the derivative. You could differentiate all these terms, and they differentiate right back to this. That's basically what the integral says. Is the integral asks you what function has this for its derivative. And this function has that for its derivative. Let's do another example. Let's say we got x squared plus 7x over 6 root x. Now, integration is a lot harder than differentiation. For derivatives, we know pretty much all the rules we need to know for almost any function. We have the quotient rule for quotients, the product rule for products, chain rule for composite functions, and you can combine all those rules to differentiate anything. Integration is a lot harder. There is no quotient rule for integrals. Instead, the only way to do this is to rewrite this. A ton of integration is just rewriting. You are given an integral, but you can't integrate that form. So you do all the algebra that you have to rewrite it and turn it into a form that you can integrate. And how to do this is we'll divide everything on top by the 6 root x. So we'll break it up this way, and then we will divide. So x squared over 6 root x is 1 over 6, x to the 3/2. Right, because you subtract your exponents. 7x over 6 root x is 7 over 6, x to the 1/2. And now we can integrate, because we know how to integrate polynomial expressions. It's not really a polynomial, but we know how to integrate powers of x. So we add 1 to the exponent, so it's 5/2. When you divide by 5/2, you multiply by 2/5. So 2/5 by 1 over 6 is 2/30, which is 1/15. So again, add 1 to the exponent, divide by the exponent. Plus, add 1 to the exponent, x to the 3/2. Divide by 3/2 is times 2/3. 2/3 times 7 over 6, that's 14/18. 7/9. And don't forget that plus c. So as we study integrals over the course of the summer, this will be one of our big things. We can't integrate this. We got to do algebra to make it more accessible for our formulas.